All right, this is the Kinematics Simulation. In this lab activity, you will explore motion. So the directions, click on the link posted below or on Google Classroom. There will be a code to access the simulation. The first thing that needs to be done is set the number of points to 5. So we're only looking at runner 1 right now, but we want 1, 2, 3, 4, 5 points. Read the instructions and manipulate the distance from the starting point versus the time graph to match the scenario. So we're going to be looking at this graph right here, distance from the starting line and the time. All right, so the question number 1 says manipulate the distance from the starting versus time graph to match the following scenario, then copy and paste the distance from the starting line graph in the space provided on the right. So we're going to be able to do this. You can take a little screenshot up here. So it says runner 1 starts at 0 meters from the starting line. So notice that this is the starting line, so I can start it at 0. From time 0 seconds to 1 second, runner 1 runs forward 20 meters. So from 0 to 1, so this is on the 1 second, runs forward 20 meters right there. Good. All right, runner 1. Okay, so from time 1 second to 2 seconds, runner 1 remains at rest. So 1 second to 2 second, runner 1 remains at rest. From time 2 seconds to 4 seconds, runner 1 runs back to the starting line. All right, so I can manipulate this, okay, well, that's 3 seconds. So I need, in the next 2 seconds, for it to go down there, and I can put that right there. So it runs back to the starting line. All right, so then we're looking at this graph and we're answering the questions. Look at the distance from the starting line versus the time graph above. When is the velocity of runner 1 negative? Explain how you know this. What makes the velocity negative? So you can even play this by clicking on this, right? You can see what happens. So when is that velocity going to be negative? So you can even look at your velocity versus time graph and see when that velocity is going to be negative. Right, and what makes it negative. All right, then it says, look at the distance from the starting line versus the time graph above. When is the velocity of runner 1 positive? Explain how you know this. What makes the velocity positive? So where on this is the velocity positive? So what you want to do is it says copy that graph. You can do that like this. So you see that copied, and then you can just paste it right onto the lab. All right, so now let's look at the next scenario. So this one's going to be a little tricky. It says manipulate the distance from the starting point. So I can start this over by basically, well, I can start over if I want. If I refresh the page, it will start over. All right, so it says manipulate the distance from the starting point versus time graph to match the following scenario. Then copy and paste the velocity versus time graph into the space provided on the right. So it says runner 1 starts at 0 meters from start line. Great. All right. So from time 0 to 1 second, runner 1 has a velocity of 20 meters per second. Well, notice it's going to be hard for me to tell what 20 meters per second is. So I can look at my velocity versus time graph, and I can manipulate this until it's at 20 meters per second. Yep, there we go. So now the velocity over here is at 20 meters per second. Runner 1, okay, so from time 1 second to 2 seconds, runner 1 remains at rest. So 1 second to 2 seconds, so the velocity is going to be 0. Great. Okay, and then let's see here. From time 2 to 4 seconds, runner 1 has a velocity of negative 10 meters per second squared. So I can do that, right? So now I know that the velocity. Now, then the question asks, well, how are you able, so what you want is this graph right here, velocity meters per second, right? So you copy that one. All right, then it says, how are you able to make the velocity versus time graph above, even though you were only able to manipulate the distance from the starting line versus the time graph? And then it says, hint, use the word slope. So that's the trick. You can only manipulate this one. So yeah, I could do this, but notice what is about the slope of this line right here in relation to that? What's the slope of this line in relation to this point? What's the slope of this line in relationship to that point? All right. So the next one says at the top of the simulation. So if I go to controls, I can go to tools. Okay, for this one, I do have to exit full screen, and then I have to go to presets, preset 1. There we go, right? So this scenario is already set up. Then it says copy paste these graphs, right? So just copy and paste the distance from the starting line, time, and the velocity versus time graph. Okay, so then it says, okay, there's a preset button. Click on it, select preset 1, copy and paste the distance from the starting line versus time and the velocity versus time graph below. Then it says, look at the graphs above and the motion of both runners. Determine the motion of the runners and how that affects the velocity and acceleration. So fill out the table to the right. So the different types of motion are going to be speeding up, slowing down, or at a constant velocity. So what are these runners doing? Like what's runner 1 doing? This red runner. What's runner 2 doing? That blue runner. Is that runner speeding up, slowing down, or at a constant velocity? Or I guess at rest. All right. Then it says, well, what's the velocity? Is the velocity going to be positive, negative, or zero? And you can look at this line, and that's going to tell you, well, what's the velocity? And then it says, well, what's the acceleration? So that one is going to be a little tricky. That one's the slope of this line. Like, what's the general trend? What's the acceleration? Okay. Then the questions of this ask, explain how direction of the velocity and the slope of the line of the distance from the starting line versus the time graph relate to each other. So you're looking at the slope of these lines and looking at this graph over here. Then it says, explain how the direction of the acceleration and the slope of the line on the velocity versus time graph relate to each other. So you don't have a perfect line here, but notice that there is a trend. I could lay a ruler on top of this, and it would be basically a straight line if I made a line of best fit. Let's see. Explain how the motion of the runner, so speeding up, slowing down, constant velocity, direction, um, direction, direction of velocity, and direction of the acceleration relate to each other. Then the conclusion question says the four conditions of motion are time, position, velocity, and acceleration. Explain how the four conditions of motion relate to each other. So once again, this is the kinematics simulation.